Good evening, everyone. Welcome to Jeranism and an important interview with the English physicist, the Advanced Fellow of Particle Physics in the School of Physics and Astronomy at the University of Manchester. He is best known to the public as the presenter of science programs, especially the Wonders of series, and for popular science books such as Why Does E Equals MC Squared and The Quantum Universe. He has been the author and co-author of over 950 scientific publications. He is the one, and thank God, the only, Professor Brian Cox. Hey, Professor, thank you for joining me today. Appreciate it.
Hey, thanks for having me.
Oh, I didn't know you smoke. Interesting.
I used to be in a band, but now I work at CERN. That's the Large Hadron Collider.
I've heard of it. I do apologize for being so late. I know it must be crazy late there in the UK, isn't it?
Well, science doesn't take a break, and it needs warriors.
Okay. You all right there? All right. Well, Let me start with something I've heard about regarding the idea that you believe in an infinite amount of monkeys. Do you really think that if we had an infinite amount of monkeys, that that if they placed them all in a cage with a typewriter each, that eventually one would write the complete works of Shakespeare? I mean, you can't honestly believe that, do you?
Well, yes, it's science, you see. Well, it's infinite, and so with the kind of infinite, one thinks, like, if you think of 100 monkeys, they would eventually produce like a booklet, and if you have 1,000, then maybe a book. But with so the number, when you get everything that can possibly happen, happens because the universe is infinite.
So if the universe is infinite, which sounds like an unprovable statement, at least to me it sounds completely unprovable.
No, it's proven, it's fact, it's known, because you see, in science, a theory is a fact, and we're talking about scientific theory, so it's a fact. Okay,
well, I guess that's my bad. So if it's infinite, then all things are guaranteed to happen, right? So there would be basically a universe where your hair doesn't look like a 12-year-old Justin Bieber. Is that correct?
Well, in an infinite universe, yes, some hair might have come a little bit sooner.
Hair might have come a little bit sooner?
Yes.
What does that mean?
Well, when you think of spheres and you think of spheres that don't have any, then it doesn't quite make sense.
Okay. So if all things are possible, then somewhere out there's probably a universe where the Earth is flat.
No, that can't be, because everything is spherical, like the spheres that I just explained. So sometimes it's so beautiful, and I just think about the big, juicy spheres, and I can't take my sight. The sizes is so gargantuan. I can't take my mind off them. Big ones and small ones and blue ones and hairy ones, like I just mentioned, and ice-covered ones, and even ones with a musty smell.
Hold on a second. What are you talking about?
Planetary spheres of all types, shapes, and colors, except flat. No, that cannot happen.
Okay, but monkeys can type out the entire works of Shakespeare.
Yes, they must, because of the infinite universe of possibilities.
Okay, so can monkeys type out a dictionary?
Absolutely.
Are there planets the size of suns in these infinite universes?
Yes.
Okay, how about planets made of water?
Oh, yes.
How about a universe created by God?
Absolutely not. It cannot happen. Only you see, only a causeless Big Bang could have created the universe. And
I thought you said every. Never mind. Well, I mean, how about a universe where we all walk on our ears and travel in space trains powered by kangaroos and koala bears that are in the cockpit?
Well,
could that happen?
Well, yes, indeed, it must happen. You understand? It must happen because of the.
Okay, so how about a universe where the Earth is flat?
Look, that is. I'm not going to swear, but that is a stupid question. Okay, because it cannot happen. That's just, it's bollocks.
Okay. So these monkeys, this infinite monkey universe by your design, do they have like more advanced brains than our ancestors did, or equal brains? Or I guess I don't understand this whole infinite monkey thing.
Climate change. Just a roll. I tell you, did this in my lifetime and prepared the theory which made everything change. And the valley, in the Rift Valley, and the brain got bigger. And in Africa. And because of climate change, everything. And so, because the theory explains it, and the impossibility of it not happening is not possible. That's what impossibility means.
Okay. Now, you mentioned global warming. Did I hear you say that? Is that a yes?
Yes.
Okay, so what about the doctored reports that show no global warming in the past 40 years, doctored by NASA themselves? I don't know if you've actually heard that data has come out and been shown.
Shown by whom? That fraud, science fraud, do you mean?
Yeah, by NASA.
No. NASA. Fraud.
NASA.
NASA fraud.
NASA.
No.
NASA. You know, we're talking about the same people, the National Aeronautics and Space Administration. They've been shown to have raised some temperatures and lowered some others to show a increase in global warming, which isn't true. You can go back to the older reports and see that they've doctored that information.
Look, okay, so what was your name again? Darren?
Jaron with a J.
Jaron with a J. No, look, I can show you a graph. The graph goes like this. You see what I'm doing? And it has a peak there. This is extreme. The peak, it means extreme.
Okay. I guess I'm sorry I ever doubted global warming then. So can we talk about your expansion theory? I know you've got a theory on expansion. What exactly does that even mean?
Well, my friend and colleague and very good friend, Carl Zucker and we were watching the screens at CERN, where I work, at the Large Hadron Collider in Switzerland/France. And it's very big. And we were looking at the screen and we saw the beep and we heard the beep. So we
no, go back to, we were talking about the expansion theory, and that's the theory you came up with about I guess the universe is expanding or something. Can we talk about that first?
This is what I'm saying. So Dr. Carl Zucker and we realized that there must be a fundamental principle behind what drives everything. So we're writing a paper. We almost have it completed, and it would be known as as the Cox-Zucker principle of expansion.
The Cox-Zucker?
Yes.
Expansion principle?
Yes.
Okay. And you're talking about working with this Dr. Zucker at the LHC, right? You guys think you found some mysterious missing particle, the Higgs boson, correct?
Oh, yes. Well, it's yes.
That's your answer?
Well, what was your question again?
Well, we're talking about you were working at the Large Hadron Collider, and you're supposed to be. You okay there?
Huh? Huh?
I think you got some powdered donut there on your nose.
Oh.
Good.
Yes.
So we're talking about the. Did you find the Higgs boson?
Yes.
Particle, the Higgs boson.
Yes, absolutely. Because the Hadron Collider is so big that we found it.
And are you sure that the Higgs boson exists, or could it be just another one of your guys' theories?
Well, when you think about a theory in science and how things exist when they're theories, so the Higgs boson, it's so fundamental as a driver behind the Big Bang, after the Big Bang. So on this side, 1 billionth of a second after the Big Bang, it manifested.
A billionth of a second after the Big Bang, you can see what happened a billionth of a second after the Big Bang?
Well, yes, with maths. So a billionth of a second after the Big Bang.
With math?
Yes, maths.
Math.
Yes, maths. So a billion of a second, after the Big Bang, all the energy moved away into space and expanded, and making all of the space full. All the empty space was filled with the massless photons, and the protons that have mass filled the empty space. And yes.
Okay. How about the Large Hadron Collider? I guess I don't really totally understand that. So how does it work? Is it like some sort of magic?
No, not magic at all, but science. The Large Hadron Collider is 60 miles in circumference, most of it in France and some in Switzerland. We accelerate protons, the nuclei of hydrogen, around 99.99999999999% the speed of light, and they go around the 16 miles 11,000 times a second, and we collide 600 million of these things together per second to recreate the conditions that existed in the universe. Less than
I think you're making that shit up. Say those numbers again.
It's
just made that up.
Well, the protons accelerate 99.99999999999% of the speed of light.
And how big is that? How big is the collider?
16,000 miles big.
16,000 miles?
Yes.
And how many times a second do these things go around?
1,100,000 times a second.
Who observes this? I mean, who actually can record that?
Well, it's a testament to the power of human reasoning. I think it means that we understand physics. It means that's one of the important things about it. It means that our understanding of fundamental physics is not horribly wrong moment. at least good enough to predict something like that.
Yeah, I asked you whether you observe these nuclei going 11,000 times around 16 miles in a second. It makes no sense to me. Who observes it?
Well, the screen monitor, and it goes beep. And we can't all look because of the space, and so, but we can hear the beep.
No, I'm asking you a question. I said, who observed the speed of these nuclei? Because what I'm thinking is, couldn't we just take the speed of light and then divide by the distance and then just -1 to get the same number of 11,000 times a second that's required by the theory?
That's never how science works. We observe these things. We do.
Who observes these things?
My colleagues and myself at the LHC, we observe these things. We have graphs.
Who counts it?
The counting, the computer counts it, and then my assistant tells me that they've counted them.
So you observe it? You do?
By proxy, yes.
Okay, so I'm saying this correctly, that a mathematical prediction then confirmed with these nuclei that are going 99.9% the speed of light.
Yes, I love maths. It's quite wonderful, isn't it? I mean, when you think about it, where would we be without maths? That's what I always think
math.
When I'm...
You mean math?
Yes. Did you say meth? Well,
no, I said math. Math.
Well, it's quite wonderful, maths, because when I'm in my deepest moments of contemplation, it's what I'm thinking.
You sure you're not thinking of meth?
Yes, I don't know why you would bring meth up.
I didn't think that I was the one that brought it up, but okay. So that's great, Brian. I wanted to say that I did have a chance to talk to Dr. Zucker, and he said you two have been working really extremely closely together. He described it as almost an intimate relationship, talking about deep research, and he said something about black hole rim probes or something. Can you tell us about those studies and those findings?
Well, really, we're looking at the energies, the fundamental driving forces. And when you think about, say, for instance, the energy of a photon, the high energy collisions, say cosmic rays, they have the energy of a tennis ball served by a world-class player.
How many particles would be in a tennis ball? I mean, is that a number that we would ever know? Can we know that number?
Well, thanks to maths. Yes,
math.
The number...
Math.
Did you say what I think you said?
Math.
Oh.
Math.
Well, the number of atoms in a 12 grams of carbon is 6 times 10 to the 23. Is it? So 10 to the 23 would be 10 to the 24 in a million particles. So in 60...
Million?
Yes.
Is that math?
Yes, that's a number.
Continue.
So million particles. So in 60 grams of carbon, that's a million in 60 grams of carbon or something.
And that's a number, what you just said?
Which? A million?
Yeah, like who counts that? Isn't that just theoretical? How could you count that number of particles in a tennis ball? Who counts it?
It's science.
Okay, speaking of science, is there any intelligent life in this galaxy besides what you find here on Earth?
Yes, because in our galaxy, the latest telescope findings show that there are 20 million rocky planets in orbit of the main sequence star, spinning in space. It's wonderful. And so 20 million billion planets that are very common and life must exist.
Okay, who measured or counted these 20 billion rocky planets?
They did. The telescope did.
The telescope counted them?
Well, the telescope captured them, and then the computer, the optic, established how many there were, and it was that number.
But to count to a billion would take 31 years. I think.
Well, I'm older than you. No, I don't hear an echo. Are you having maths again?
Math?
Meth.
Nope. Math.
No. Okay. Yes.
Okay.
So, absolutely.
Math. Okay. It must be me. So who exactly measured or counted your 20 billion rocky planets? You said the telescope did.
So science works like if in theory you take the space expanding and how much is in there, and you can look at this with a telescope, and then you count them on the telescope for a brief instant of time is captured there, and we can deduce by how many we know have rocky planets orbiting those local suns. If we extrapolate how many stars there are, which is at least 3.12974 billion stars, so and at an average of 4.7 planets per star, rocky planets that can sustain life.
I kind of lost you.
Oh, well, yes. This is science. Is not for the slower people.
Excuse me.
You're excused.
Go back. Start where you. Start over again.
So, which bit should I explain it a little bit more slow? I see you're in America. You're not.
That is true.
Oh, okay. So I will slow things down. So there are suns in space, and they are stars, and they have rocky planets, at least 17 million billion trillion of them, local.
Who counted that?
The scientists with the theory.
With a theory?
You see, like I said earlier, scientific theories are facts. So if the theory says 17.23 trillion, then that's a fact.
So in science, theories are facts.
Yes, absolutely. And it's beautiful.
Science is beautiful.
Yes, how it lets you see the world. I don't know if you've been to the Sala de Uyuni in the Americas. It's so expansive, and you can see the curvature. with your own eyes, there standing, I'm just over 6 foot tall. You can just see it curving. You can see it curving all the way around. In fact, when the sun goes down over my left shoulder, because it's in the southern hemisphere, it goes down over my left shoulder, and I can see it rising over my right shoulder.
Okay.
Okay.
Can you tell me how we came up with the sun?
Well, that's quite simple, really, when you think about it. If you know the distance to the moon, and you know how big the moon is, and you know how big the sun is compared to the moon, and you know how far away it is, then you can deduce its distance from the Earth.
How do we know how far away the moon is?
Because observation tells you how close it is. It's much, much closer than the sun.
And they appear to be the same size in the sky.
It's a quirk of nature, you see, and they are both, you'll agree, spheres. Spheres. So the moon is much closer. We can tell this because we can see it quite clearly at night. If the sun was there at night, we wouldn't see it because it's too far away.
Couldn't it be a creation?
Well, yes, it's a creation of the Big Bang.
So it could be a creation of God. That's what you're saying.
No, that just sounds like bollocks. Yeah,
but you just said that it was created by random event. So in an infinite number of universes, it could also be created by God.
No. When it seems random, but it's ordered. It's the laws of physics going back in time. If you think of a domino effect going back in time, so you have the very first, and that was the Big Bang.
That was the very first one.
Mm-hmm. And that set off the whole chain of events that we call the laws of physics. And these help us establish things like how close the moon is, how far away the sun is, and how they're both spheres.
Okay. I guess I'm going to have to take a note on that one. Now, it would be fair to say then that we are spinning on a ball Earth, correct?
Well, obviously we must be spinning because we're on a sphere. If that sphere wasn't spinning, then gravity wouldn't have the push-pull effect that it has, and we can see the stars.
Oh. And
well, you can see.
You also believe we're going 1,000 miles per hour around the sun.
How fast did you say?
I actually think it's 66,600. I don't know. You would know it's math.
Yes. Well, for an instant, I thought you said 66 miles an hour. I was going to say that's ridiculous.
Okay. No, actually, it's 66,600.
Yes, I know.
We don't feel it?
No, it's relative. You see, when you get up in the morning from your bed and you've been lying down, you've got a cover on you, but you don't notice the cover because it's been on you all night. And then when you get in the shower, then that drastic change is what tells you haven't got your bedclothes on you anymore.
What if we were going 1,000 miles per hour in our bed when we know we were going that speed?
Sorry, 1 second. I'm having technical difficulties. One of the monkeys has just given me these. So,
the infinite
monkey. The infinite monkey. Yes. Well, they're quite intelligent things. We came from monkeys, you know. Let me test. Working perfectly fine.
I don't think you're actually testing anything.
Yes, this testing. Can you see?
I I don't have an echo anymore. Thank the Lord. What?
Yes, it's you mean thank science. Yes, you see the technology we're using. People think it's
that powder in your hair there.
I don't. That's quite offensive. I find that quite offensive, to be completely honest with you. I don't talk about your rosy cheeks and your kissy lips.
You got white powder all over in your hair.
No, it's not. So, where were we?
We were talking about 66,000 miles per hour in a orbit around a 93 million mile distant sun. And you were saying that you believe that bullshit?
Well, if you're going to call things bullshit, I know what's bullshit. That pink monkeys don't wear shoes.
Would they in a infinite universe?
Yes. And in that universe, they too would have laws of physics, which would dictate to them how tight their shoes would have to go. Otherwise, they wouldn't be able to climb anymore.
Maybe the monkeys don't climb.
Well, then the terrestrial land-based monkeys like humans. And we have shoes. Therefore, it's proven.
Okay, and in another universe, the Earth is flat. I got you.
No, that can't happen because, you see, it follows, science must follow the rules established by the Big Bang of physics, those laws. So everything is a sphere and everything out there is a sphere. So to say that something is like, say, a flying pizza through the universe, it wouldn't even get baked, would it? It would have to be very close to the sun to be baked, and things would evaporate.
Kind of sounds like a little bit of dogma.
Well, dogma, I think, is more for the realm of religion, and science doesn't have dogma. We have theories and facts.
You don't have
peer
dogma.
Review.
Like gravity's not dogma.
Peer review. Peer review.
Can you explain peer review for me?
Yes. Peer review is what stops us from having dogma, because so when Dr. Zucker and I write our fundamental principle for the expansion of the universal energies,
the Koch-Zucker paper.
That's right. And I don't want to pat myself on the back, but so it was my idea, and he's very good. He's lovely.
That's why your name goes first, Koch-Zucker. I got it.
Yes. Yes. The peer review process guarantees the validity of the science that's gone into the peer review system, to guarantee that dogma doesn't creep in. We can't be like the theologians, just counting how many angels can dance on the head of a pin.
Didn't you tell me earlier how many particles are in a tennis ball?
Yes, I think it was 10 to the 23.
24.
24, yes, thank you for that.
Million.
But that was in 60 gram, but the tennis ball is 24, or is it 12? And then you have to factor in the force, Newton's law. So yes, the law of motion, and how a body must remain at rest unless acted upon by another body. When the tennis ball hit my head moved forward, and so I know that there was force behind it.
Oh, you mean everything has to have an equal and opposite reaction?
Yes.
And so when we talk about the Earth spinning, what's the equal and opposite reaction to that?
Where the Earth was.
What?
Where the equal and opposite. So the Earth was here, and the opposite of the Earth being here is the Earth not being here. So when the Earth is here, there's the opposite. And the Earth being here is equal to when it was here. So when it is here, this is the equal and this is the opposite. See, it's quite simple, really, if you understand science.
Okay, and together with the sun, the Earth is going 480,000 miles per hour around the galaxy.
Yes.
Have you measured that?
Well, no, but science has.
How does science measure that?
Well, you know how with mathematics you can take a thing, transform it into mathematics, and then work with it so that, well, this is how science works basically. You think of a prediction, you then write the maths to prove that prediction, to yield that answer you predicted, and therefore the answer confirms that your prediction was correct.
At what point do you verify that with reality?
Well, you know, when you're checking your maths, so you check your maths.
That's not reality.
Well, it's real. If you take away maths, then you don't have computers, shoes, headphones, teeth.
Good point. No teeth. If you take away the math.
Yes. Because teeth, how many teeth do you have? 28 at the top. So that's a number. That's maths.
Oh. Okay, I got you. And the galaxy is going 2.2 million miles per hour.
As far as we can detect, yes.
Who's we?
We people who think long-range thoughts, superluminous thoughts.
Okay. And the closest star is 25 trillion miles away?
Well, depending on the time of year.
It changes.
Yes.
Okay. And these things are all facts, because I could be lost. I could be in another world. I'm having a hard time finding these things to be true. Trying to find the facts, and you're not really helping me much.
Well, I sense a little bit of resistance in you, because I think that you have an ego problem where science is a little bit beyond you, so you feel overwhelmed by it, and whatever a scientist says, you dismiss because you intuit that they see you as inferior. They don't. They understand that you're a unit, just another unit of resource, just like they.
Yeah, we're all insignificant remnants of supernova bits.
Well, it's quite magical, really, if you think about it. The number of stars, the number of atoms in the universe, the quarks, the distances between things that are ever expanding is quite magical, really.
So you've been out in space and done the hands-on experiments that are required by science?
No, but I'll tell you a funny story. I was at the Large Hadron Collider with Dr. Zucker, and Tim Peake, you might have heard of him. He's quite a famous British astronaut. Tim Peake came in. Tim Peake came in, and he kept throwing his tea in the air. It was very funny. He was throwing it in the air because he'd forgotten he was no longer in the International Space Station orbiting the Earth.
Yeah, why don't you explain to me orbits? Let's just start something simple.
Well, where would you like to start?
I'll enjoy this peach, which is a sphere, by the way.
Yes, quite lovely. Can I see it, please?
Yeah, it's not bad. Pretty good.
Ooh, that looks, ooh. Yes. Where would you like to start with orbits? You see, orbits, once something is in orbit, it might as well have never started, because it will never stop. So the equals and opposites is infinity.
Oh. What about the centripetal force or the centrifugal force? Well, are they the same?
It depends what setting you have your washing machine on. If you have it at 1800 cycles, then it's quite a lot of centripetal force. But if you have it off, then there's 0.
Do you know the equation for the centrifugal force?
Mm-hmm.
What is it?
Oh, it's rather complicated, and I don't want to belittle you by quoting it. So, but I can tell you this.
Thank you very much.
It's okay, you know, because you see, since I started doing boxing to relax, you see, these are my boxing gloves. I have
you're boxing?
Yes, for relaxing, I do boxing, and my trainer, she's quite lovely. She has a little bit of a deep voice, but we don't mention that because, well, it's each to their own, but she's very good. And so since I started boxing, it's allowed me to just let go of all that animosity that I was feeling towards people who say that the earth is flat and things like that. And I can see you as a human being desperate to be held. So it's okay. I can talk to you one-to-one. You don't want to be held?
No.
No. Oh.
Nope. I just want the truth, and I don't think it's coming from your boxing team over there.
Oh no, well no, they don't know about science. They just know about grunting and sweat. Well, but as far as your question goes of the orbit centripetal force, I think you're asking about how does a body not spin off into space? Am I right?
Yeah.
So when you have a body orbiting another body, the body that's being orbited must have a bigger mass and therefore a bigger gravitational pull. This is what keeps the orbiting body from going further away. It's at its limit of the spin away points. That's the centripetal, the pushing out, and the centrifugal is the gravity, and it's on that very fine layer, that groove, its most optimum groove. That's what's keeping it orbiting the larger body.
Isn't it true that they are the same formula, the same mathematical formula for both?
Well, if you want to look at it that way, yes.
So the same formula for the force that's pushing you away and pulling you in.
Well, if you think about this, I'll simplify it. If you say that 2 is the same as 2, so let's say 2 is centripetal formula, and let's say 2 on the other side of the plus is the centrifugal formula. So you have 2 plus 2 equals 4. 4 equals orbit. 2 plus 2 equals 4. Centripetal plus centrifugal equals orbit.
So when the Earth is coming towards the sun and the sun is pulling it towards it because of its gravity, and then the Earth swings around the back of it and starts heading off in the other direction, why is it no longer pulling it then?
Well, it's still, you see, there's no up in space. So when you say round the back of it, there's no back in space. So it can't be round the back of it. It must be there.
I have to tell you, you're not really impressing me, Mr. Cox.
Maybe it's just because it's so late in the night and you're quite exhausted.
It could be that. It could be that. I don't have any of the powdered donuts that you have.
Well, I would have shared, but you're quite far away, really.
I don't think you would have shared.
I would. But you said you don't like being held. So maybe, I don't know, would you like being held for a donut?
Nope.
2 donuts? With jam? Sorry, that's jelly in the US. Nope. And frosting?
Is that what you have in your hair there? Still kind of confused what's going on there.
No, with my hair, the stress of being so important and doing speaking tours and television.
Gotta be real tough on you.
Debates. It does, yes. And people have this habit at the Large Hadron Collider, that's CERN.
Heard of it.
They clap their hands over my head after they have the donuts. It's a little ritual we have.
So I have a question about the CERN. Why in the world would the logo for CERN be a 666?
Well, if you think about 666 in a religious sense, it's quite an ominous number. But if you realize that the religious significance of 666 is quite absurd, given that it comes from a pseudo-theological background, you find that 666 is actually quite a lovely shape.
It's a lovely shape?
Yes. Well, it's a sphere. If you think about it two-dimensionally, it's a sphere with a little tail for orbit.
Aha. Well, you can think of the flat Earth as being a sphere then. It's a two-dimensional sphere.
But then where's the tail?
Touché. So do you have any questions for me? Because I think you're just kind of doing drugs over there. And
No. This is herbal. It's medical. So I have some questions for you. You are a confessed flat earther, are you not?
Confessed, yes.
What religious structure does your flat earth have? This theory, flat earth theory. Do you have to pay tithing?
No tithing. No 10%.
Do you receive tithings?
No.
Are you the Pope of your flat earth?
There's no Pope.
There's no Pope?
Now you're thinking of Catholicism.
Okay. Well, tell me this then. Why don't you fall off the edge?
Are you being serious?
Yes. If it's flying through space and there's an edge of waterfall.
No. See, that's the whole problem, is that's what we were all taught. That's what we were all shown. But it doesn't have to work that way just because somebody told you. I know you're very into just accepting what you're told, but you should look into some of those things. You might be surprised.
Well, I've heard, this might be just a silly rumor, that there was cake on the flat earth. Is this true?
We do have cake.
Fascinating. Does it have frosting?
Usually it has frosting.
Is it just sugar dusted on top, or is it frosting?
No, it's just regular sugar.
Oh, well, then let me tell you this.
Not your kind of cake.
No, not at all. Let me ask you this. What's an eclipse? And what is a tree?
I have no idea what a tree or an eclipse is. Let me ask you a question, if you don't mind.
No, go ahead.
Do you understand geodetic surveying?
Yes.
Okay. And if we had somebody in San Francisco and they were measuring going east, and then we've got somebody in New York who's measuring going west, they would both see the Earth is falling away from them, that the curve is going down.
Okay.
So if they started walking towards each other and measuring the curvature, when they got to the middle, let's say Colorado, would they both be down inside of a cavern, or would they be in Colorado, which is a mile high?
It depends what the one from San Francisco is called.
He's called Zach.
Zach. And is he wearing clogs?
Nope, sneakers.
Okay. So what was your question?
They were surveying, going towards each other, measuring the Earth falling away from them, both of them. So how do they get to Colorado and they're a mile high, not 30 miles deep?
I think you don't quite understand the curvature equation.
I clearly don't. No, I don't. Can you explain that to me? Because that'd be like extremely helpful.
Yes. So this is what happens. You have your horizon and you have your point of view, and you have your height from the floor to your head, your eyes, the thing that you see out of, and the horizon. And then the difference between your eyes and the horizon is the distance. And that's how far you can see. And you can't see any further because it's just missing from your line of sight because of the curvature. That's why you can't see Europe from the United States.
Okay, so let's say that there's a huge body of water in the middle of the United States, and somebody in New York watches the boat go over the curvature. So the boat's going down the curvature, but somebody from San Francisco would also see the boat leaving them going down the hill. So how can both boats be going down? How does that work?
Is this person from San Francisco watching the ship go down also Zach?
He is Zach. He's wearing sneakers.
I don't think this Zach character is very reliable, to be frank with you.
No, this has been peer reviewed.
Oh. Has it passed the peer reviewed?
Definitely. Been a lot of people measuring it, and nobody's finding the curvature. So I guess what it comes down to is what would happen, and this is just purely hypothetical, what would happen if you learned that everything that you were ever taught was, for lack of a better word, a lie? Like, I mean, basically, if it was a deception, and so since you don't get to go to space, have you been to space?
No.
Okay. So it could just be numbers on paper, since you consider that to be reality, right?
Yes.
Okay, so what if, just because they tell you you are traveling at 66,000 miles per hour and going around the galaxy at 480,000 miles per hour, and the galaxy is going around the great attractor at 2.2 million miles per hour, and this great attractor is 100 quadrillion times the size of the sun, couldn't you see it possibly being nothing more than words and numbers on paper? Like, what would happen if you realized that it was all a lie?
And I'd wasted my life.
Yeah, this is hypothetical. I'm saying hypothetically.
Oh. Whew. Huh.
But also, you should think about it, because if you haven't done any of the measurements yourself, for instance, in this Large Hadron Collider, you've got these so-called, you told me, what is it? The nuclei of hydrogen?
60 million of them per second.
Yeah.
600, 600 million of them per second.
Right. Going around a 16-mile track. 600 million of them.
Yes.
Okay, so do you see how that could be a complete and total lie?
Well, I can't dematerialize and enter the Hadron Collider. What kind of fantasy world? You can't do this to test whether something's true or not. I would come out dead.
So where's the verification? That's what I'm trying to get at here.
I tried to explain this to you earlier. On the screen, and my assistant looks at the screen, and he sees the graph. Sometimes it's a she, and depending on the shoes.
You're talking about a computer. A computer is giving you the the data sets. It's giving you the results.
That's right.
So let's go hypothetical again. There's a man sitting behind a curtain somewhere who's typing in the answer that you would, of course, come to if you were trying to prove your theory by simply taking the speed of light and figuring out how many times those particles would go around at the speed of light, and then just -1 to give you your 99.999999.
Would this character behind the screen, would this be this Zach of yours?
Nope. Zach's gone. I'm more talking about some nefarious kind of deviant person who is tricking, obviously, you.
Well, I'm more curious to know where this Zach has gone.
He's measuring the drop of curvature.
Oh, okay. Well, so in your hypothetical world, let's see. You have a hypothetical character behind a screen punching in numbers to come out on another screen. This one, a crystalline screen, whereas the other one is more of a curtain screen. Am I
Doesn't
right?
matter. Screen could be an iPad.
Okay. To yield the result that we're expecting.
Right, because if you got funding to find the Higgs boson and you didn't find it, then it would be hard to get funding in the future.
But,
so it would be better for science if you found what your hypothetical theory called for. And when you found it, then it looks like you did something important. And then next time you say you're looking for something, you're more likely to get funding.
well, yes, but you have to remember this. You have to bear this in mind. With the Hadron Collider, a large portion of the fund that we receive goes towards the power consumption, the electricity that's used by the Hadron Collider to create the electromagnetic waves that push those hydrogen particles around. Without the funding, we wouldn't be able to pay for the electricity. So this would bankrupt the electricity company, and then what would the pensioners do?
I don't think you're even understanding what I'm saying.
Well, will you say it in a different way?
Sure. Do you think it's possible that you've been fooled? That everything you've been told is a lie?
Well, that's a tricky one, because you see, in a world of infinite possibilities, yes.
Like the flat Earth?
No, you see, it has to be a sphere. The laws of physics dictate that in all of the universes...
Do you understand infinite possibilities?
Yes, but all the universes must yield to the laws of physics. For instance, all of them must have space.
Well,
all
the laws of physics would say that your monkeys cannot, they're all monkeys.
Well, you're confusing the laws of physics with the theory of the monkeys and how they went to script writing school and the rest of their studies. You're mixing apples and oranges here.
Okay.
So either you have to stay in one field of the laws of physics, which dictate that all universes follow laws like space.
But in an infinite amount of universes, there would be an infinite amount of physics.
I thought this was going to be a scientific discussion, not a philosophical discussion.
You said earlier that it was science.
It is science, and science says yes.
That all things would be possible in an infinite universe.
When it comes to, but that's when it comes to monkeys writing scripts. You can't then say that these monkeys all also learned how to put each other's hair in corn rolls just because they can write scripts. Why would they do that? Ask yourself
Tell
that.
Tell me, Mr. Cox, why do we exist? Give me that much.
We exist because we have to. You see, just as the sun has to exist and the earth has to exist and space and expansion and everything else, we must exist too. We are like an automatic response to what started at the Big Bang. It's inevitable. It was inevitable that we would exist.